Hello viewers, my name's Alan and welcome back to my home workshop. Okay, well my lathe is a 460mm swing, or just over 18-inch swing, and a metre or a yard, I guess, between centres. The tailstock's quite heavy, and you'll see in a later video just how heavy it is, and it's actually quite awkward because to slide the tailstock from one end to the other. Typical scenario, maybe you just finished a facing operation and you want to get up there with a centre drill, so you've got to have the tailstock up the far right hand side, give yourself plenty of room to move. So now you've got to drag the tailstock back to the front, do your business, and drag it back again. And yeah, you can do it, but it's not that easy. You have to basically turn from the waist, which is ergonomically a terrible thing. So I decided I needed to do something about that. And what I decided to do was actually fabricate a mechanical cranking mechanism, so I could move the tailstock with some mechanical advantage and reduce the amount of effort required to do it. But most importantly, avoid injury from awkward exertion and twisting, and I don't want to do that. And also to get some fine control, so that when you're trying to move the tailstock close to the job in the chuck, you don't accidentally slam the centre drill or whatever it is you've got in the chuck into the work. So that's what we're trying to do. So as I said, the tailstock in this machine is a pretty hefty chunk of iron, and I've rigged this up with my crane scale so you can actually see how much weight is involved, and hopefully you can just about read that up there. That's sitting on 62 kilos. That's a bit more than I want to heft around, and once it's sliding along that bed it's got quite a lot of momentum. Anyway, so I decided that some way to move the tailstock under control was definitely in order. I've seen other big lathes with a winding facility on the side of the tailstock, so that's what I was using as a guide. I wanted to use the existing carriage movement rack, which is up under here. Now I needed to be able to fabricate with welded steel pieces though, because I don't have any casting capability, and I wanted a crank handle that was removable. So I needed to preserve access to the tailstock alignment features for setting, not sure what you call it, but adjusting it on the centre line of the lathe, so I couldn't block those off. And the sides of the tailstock base are as cast, so there's a draft on there, a casting draft. So I needed to machine a flat area that I could actually fit my thing to. I thought about using an idler gear so that when I wind the handle, it actually was more intuitive that you want the thing to go that way, you wind that way. But the reason I decided not to do that in the end is that the idler gear would just take up more space, and I wanted to keep the whole thing as compact as I could. And as is the case for most of my projects, I try and use the stuff that's to hand rather than having to rush out and buy special material every time. So the scrap bin was going to have to provide for this job. This is what I came up with. It's fabricated from a big piece of angle iron here, with a clearance groove cut in it to clear one of the V-ways, the outer V-way. And you can see I've welded a plate on there, and some fillets on the side, and then drilled some holes, slotted some holes. So this was a piece of 20mm square mild steel bar, bored 16mm to take a couple of brass or bronze bushes. That was for compactness. I did think about using ball bearings, but the bronze sleeves were much more compact. And I put in a little oiler to keep it happy. I didn't in the end make the gear. I was originally thinking I probably would, but I chickened out. Well, also I could buy this for $40. It didn't seem like Well, I guess I just haven't tried to make gears yet, so I took an easy way out. I drilled it to take a number naught taper pin, and the end float. And the shaft is actually made from a 1/2 inch UNF bolt. And this was the threaded end. That was the head end. Cut that off, and this is a good fit on that shaft. Kept the threaded bit, and when I did the assembly, I used the nut to adjust the end float on here, and this is actually Loctited in position to preserve that end float adjustment. I did think, and the original design allowed room for an idler pinion, so that I could get the movement in the right direction when I turned, intuitively. But in the end, I couldn't. I just didn't think it was worth the effort, and I didn't want to take up all the additional space. So that was how. Oh, and this was just a bit of 6mm plate. So it seemed to work out all right. So as I've said, I milled a flat on the side here. Had to lift the tailstock off, obviously, to do that, and I dismantled the this top unit from the base, bolted this to a big angle plate, put it on the milling machine, and Bob's your uncle, or Fanny's your aunt, or something. Anyway, and then there's 4 1/4 inch set screws, and the holes are slotted to allow me to adjust the engagement of the pinion with the rack underneath. Oh, that's the first one on the floor. Also, to get this on, you have to, the rack ends here, so to get it on you have to push it in at this stage, at this end, so the pinion can go in past the rack, and then it's possible to line it up. These 4 1/4 inch bolts, possibly overkill, but don't like doing jobs twice. If you make it strong enough the first time, you never have to do it again, do you? So leave them loose. And lift it up lift it so the pinion is brought up to contact the rack. Just don't pull it up tight, that's all. There's a little bit of clearance. I haven't bothered with spring washers. I don't think this needs to be terribly tight. It hasn't come loose. It's obviously been in play for a while now. I've probably had it on the machine for a couple of years now, and it hasn't come loose, so I've been quite happy about that. Okay, now to move it, I used an old 1/2 inch square drive ratchet and a 3/4 inch socket that fits on that nut, and bent the handle round at 90 degrees to get the crank action I wanted. And to move the tailstock that way, you have to move the handle the other way, like that. But it's quite easy to move it. Back again. Oh, it's been a great success. The only issue that really comes into play is when the tailstock approaches the carriage. You have to be careful of a couple of things. First thing is to make sure that when you swing the handle around, you don't knock the machine on. So that's one of the reasons for the ratchet. But also you've got finer control. And the other thing to watch out for is that it will actually, of course, if you're not careful, clout something on the back of the carriage. And the first thing it would try and hit was the thread chaser, but if you take the thread chaser off, then it will of course try and hit there. So I haven't found that to be an issue though, and it's certainly a hell of a lot easier than it was before trying to drag that heavy weight.